Hello everyone, welcome to ILUSTRACA. In this video, I'm going to explain about a new software which is known as STRAP. This is a structural analysis and design software actually. So today I'm going to explain how you can create a structural model very efficiently in this STRAP software, and how you can analyze and design your building in this software. Actually, I'll be uploading a series of videos on this software where I'll be explaining elaborately about the analysis and design process of a building structure in this particular software which is called STRAP. So let's start. So this is my framing plan of a structure which is a commercial structure, and this is a G+4 building. So this G+4 building is very simple building because this is the initial video, so I'm going to make it simple only. So this is the these two parts are my showrooms, and this is the lobby area. Here I have one lift core, and this is a 3-flight stair, you can say. So this structural model I'm going to create in STRAP software in a very efficient way. Okay, so what we can do now, first of all, we have to create the beam and column placements like the framing plan separately in a DXF file. So let me show you how I have created. So this is a DXF file that I have created, and here you can see these are the beams that in a proper way. Okay, these are the beams, and the yellow one are my columns. Here I have created the walls, and all the structural elements are in different you can say in different layers. Okay, the beams are in one layer, the columns and the walls are in different layer. Okay, and suppose you have some opening, let me create one. If you have some opening here in the slab, so what you can do, you can create a another layer called contour. Okay, and you can keep this hole, or you can say the opening in this contour layer. Okay, so in my model there is no hole or no opening now. In this part I might be having one opening, but I can create it in different way. So this is my model, DXF model. Here this beam is very small, you can see. What I can do afterwards, if there is a need of changing the thickness or changing the width, you can say, I can change it in the STRAP software also. So this is my initial DXF file. So to create the STRAP model, there is a, if you install the STRAP model from their website in the ATIR, you'll be having their website. I'll be keeping the link in my description. So if you go through this link, you can have a trial version of this software, and with this software you'll be having one additional software or additional plugin, you can say, which is known as Auto STRAP. So let me open the Auto STRAP first. So this is the bunch of softwares you'll be getting with the STRAP software. So this is my Auto STRAP, and I'll be opening this. This is the Auto STRAP interface. Actually, there is no need of explanation of this interface, because with the work I'll be doing in a while, you'll be getting the interface very easily, because this is very simple interface. So what I'll do now, I'll first import that DXF file that I have created in AutoCAD, okay, or any other drafting software. So let's go to File and New Import DXF file. Here if you see, I have created one demo2, and there is my DXF file. I'll be opening it. Now it will ask you the first question, which is in which unit, what is the base unit or of your drawing. So I have created my DXF file in meter unit, so this is in meter. After that, you have to keep the units, program units here, like in which unit you want to see your model. Okay, so I want my lengths in meter, the sections in millimeter, so I'll be changing it to mm, the forces in kilonewton, and the material will be obviously concrete. Now this is the use of the layers, that I have created different layers. So this is my drawing layer. Now this drawing layers you can directly assign to the model layer. Okay, so my zero layer is there is no need of assigning anything in the zero layer, because I haven't created any structural element here. So this is my beam. Obviously this will be created in beams. You can see there are several other options. So I want my beams in the beam, and the columns assigned to the columns. The depth point, okay, there is no use of this layer, and the walls will be assigned to the walls layer. Okay. Now if you click on OK, you can see here the DXF file we have imported, and all the dimensions. Okay, there are some default dimensions. So these dimensions are there already. There you can see TH1 means that it is showing the thickness of the slab, and these are the beams, which is 457 by 600 as default value. I'll change all these values actually. And for the columns, according to the section of the column, it will consider the column size actually. So at the very beginning, what I will do, here you have the parameter option. If you click on parameter, you will have this beam section. So I want all the beams in a particular size. So let's click on select all beams. Otherwise you can select the individual beams also. So I'll be going with all beams, and I want to change the total section. So define a section and click on OK. So now I'll be taking a section of suppose 300 by 600 or 550. I don't know actually what should be the actual size, because this is the just initial process, and over the period while designing I'll be knowing that what should be the proper size for this building. Now this is a G+4 commercial building, so in that case I have taken some higher value. So here also you can have option for rectangular or T section. So I have taken the rectangular option here. Click on OK. Now what you will see, you're gonna see that all these values, this drawing is okay, this drawing is not going to vary your sizes. Okay, the drawing will be as it is as your DXF file, but the sizes will be changed in the mathematical model. So this is my 300 by 550 beams. You can see all the beams are changed to 300 by 550. Okay, so what if you want to change any individual beam or the size of any individual beam, you can select the beams individually and you can change the size. Okay, now suppose I want to change the thickness of this slab. Okay, now this thickness of the slab we can change in our strap software also. There is no need of changing anything here. I'll do it in strap software. It is better. The one thing what you can do, see, this is the lift code, so there will be no slab here, there will be opening, right? And at the very top where the lift machine room will be there will be one slab. So what I will do, I'll make a hole here, okay, or you can say an opening here. To make a opening here, what you can do, you can go to thickness. I want a individual space and select this individual space, just double click it, and here see it is written here that if you want to create a hole or you can say opening, you have to make it -1. So let me make it -1 and click on OK. Now to see whether the opening we have created it is there or not, here you have option display mesh. Click on display mesh and you can see the total area is meshed as there are slabs, but this area it is opening. Okay, now how to differentiate whether there should be a slab or not, because at the top floor we need one slab there. Okay, so this is the typical floor plan. What we can do, let's go to levels here, and suppose we want G+4, right? So 5 levels of 3 meter height. So number of levels added, it will be 5. Level of height will be 3 meter. Click on OK, and this is my, and see in every level we have assigned one drawing that we have imported here. Okay, now click on end. Now I'll be going to DXF file, and this is my DXF drawing which I have changed here as per my requirement. Now I will add another DXF, the same DXF for the top floor. So let's go to add DXF, and I'll be taking the same one, open. Everything will be same. Click on OK. Now see, if you have two options, one is both the named in same, actually drawing 1, drawing 1. What you can do, if you have different floor plans, you can make different DXF files with different name. It will be easy for you to understand afterwards also. So let me show you the this is the previous DXF. Okay, let me make it the mesh. See, this is the new one because there is no mesh here. See, there is no opening here, sorry, there is no opening here, but this is my previous one where I have opening. So what I can do, I can take this second DXF file and I can assign this DXF file to my particular level, or you can say that to the top level where the lift machine room will be there. So let's go to let me change it first, the sizes, beam sections, all beam sections, and I'll make it to 230 by 300 by 550 it is, and click on OK. Okay, I don't want to change the thickness of the slab because I'll be changing it to a different software which is called the strap software, which is our actual analysis software. So yeah, so now what I'll do, I'll go to levels, and at the top of the floor, means my terrace level, I want my lift machine room to be there. So I'll change the drawing to drawing this one. Okay, so let me check again whether the second drawing we are having the slab, in the first drawing we do not have slab. So obviously go to levels, I'll be selecting the second drawing and click on end. Okay, so let me go to the first drawing again, drawing 1. Here what I can do now, I have created the mesh. See, this is the mesh. If you want to change the mesh size, you can change the mesh size. See, this is the mesh parameters. Select all space and you can change it. See, it is now 500 mm by 500 mm and minimum size is 200 mm. Wherever it is required to make a smaller size of mesh, then it will make it to 200. Okay, if you want to change it, you can change it from here. I'll be going with the default value only. You want to make any opening in the wall, you can, suppose I have one core wall here. If you want to make an opening, you can create from here. In my next videos, the advanced videos, I'll be showing all these advanced options. So this is the basic one. Now what I have done, I have imported two different DXF files. Suppose you have created DXF files in two different AutoCAD files or two different AutoCAD you can say layouts, and you don't know actually whether both the DXF files are in same place or not, in same coordinate values or not. So what will happen if the DXF files are not in same place or same coordinate position? The top floor, as I have assigned two different drawings in two different floors, the top floor might be shifted to different place, maybe in different way. Okay, so to align all the floors, all the drawings in a particular point, what I'll do, I'll take a reference point. So I'll go to origin. See, I'll go to the drawing 1 and origin, and suppose this corner, or suppose anything, any corner, maybe this corner of this wall is available in the top floor also. So I want these corners or this position to be aligned. Okay, so I'll take any line and click on OK, and I'll make this point as my reference point. So I'll go to the second drawing, and again see, now in the second drawing this is the origin position. So I'll change it. I'll go to origin, any line and OK, and I'll select this. Now these 2 points are aligned in every level. Okay, so this is what we can do with the AutoStrap software to create the structural model easily. Now this is not the end, we can go for basic loading also. Okay, let's go to loads here. Here if you have loads option in the right hand side corner. So I'll go for the slab loads first. Go to slab loads, and I want individual loads but in multiple selection. I'll take individual spaces, this one, and double click the selection I want to end selection, and here you can actually write the values of your load. Suppose 1.2 kilonewton per meter square I want the dead load, and the live load I suppose I want as 2 kilonewton. And here see what we are going to do. We are going to transfer this slab load to the beams, right? So in that case, what I'll select this one, beam loads bidirectional. Means whatever load we are giving to the element, this element will transfer these loads to the beams, right? This is the work of slab, right? It will transfer the loads to the beams. So I'll be taking this one, beam loads to bidirectional, and I'll click on OK. So you can see the load values are displayed here. Let me take the slab load again, individual space. I want this specifically this one, lobby area. Dead load will be 1.2. As it is a lobby or passage, you can say. So the live load will be suppose 3 kilonewton, and it will be beam loads to bidirectional. And I do not want to add the self weight here. Okay, I'm going to assign the self weight in a different manner in different software. So click on OK. So here, this is the loads. Now these three slabs, these are actually the stair part. So what I want, instead of creating the stair here, I want to transfer the load of the stair in this two particular direction, in one way direction, just to create the proper load transfer. Okay, create the phenomena of proper load transfer. So to do that, again go to slab load. See this, for these two slabs it will be in same direction. So I'll go with multiple selection and individual spaces. This one and this one, double click and selection, and here I can go with the angle value. See, angle 0 means it's in this particular direction, 0 degree direction, and if you keep this one as 90, it will mean vertical direction. So as we want to transfer our load in this horizontal direction, so I'll be keeping the angle as 0, and see the load will be transferred 50% in this side and 50% will be this side. Okay, so I'll make the dead load as 3, live load as 3, as it is a staircase. Okay, then click on OK. Now you can see this is the direction of the load transfer. It is showing one way, and these are the values. Same way, slab load, individual spaces. For this slab it will be in this particular direction, which is my vertical direction. Double click, I'll go for angle and I'll make it 90. The value of dead load will be 3, the value of live load will be 3. So this values I'm taking a standard value. What you can do, you can calculate and you can put the values. Okay, so click on OK, and now here you can see the direction is in this way. So here the load is transferring in one way direction. Okay, fine. So after that, so the loading is complete, slab loading. I'll go to the drawing 2, and this is the terrace part. So I'll go for slab, individual, multiple selection, individual spaces. I'll select all these slabs actually, and selection, and I'll make suppose the dead load. There will be very less dead load if there is no waterproofing. So let's consider the waterproofing also. So a very value of 1.5 kilonewton of dead load, and live load, as it is a accessible roof. So what you can do, you can make it 0.75 if it is non-accessible, or you can do as 1.5 also if it is accessible. Okay, so dead load of 1.5 and live load of 1.5 I have taken. Same here, bidirectional loads it will be. Then click on OK. So this is, you can see the two-way symbol it is showing here. I think in the drawing, the first one, what we have done in some cases, let me see. Slab load, individual space for this one. Okay, bidirectional is okay. Slab load, individual spaces. Sorry, escape. Let me escape it. Slab load. So we need to make it as bidirectional. Otherwise, okay, we have given angle value, so no need of bidirectional actually. Yeah, so yeah, going to the drawing 2, means our second drawing, and here the stair loads will be the same. Individual space, these two, double click, dead load 3, live load 3. It will be in angle direction 0. Click on OK. For this load, this particular space, dead load 3, live load 3, and the direction will be 90 again, and click on OK. Now see, for this space where I'll be having my lift, what you can do, you can calculate the dead load and live load of the lift for the particular space. So let me take a value of 10 kilonewton per, or suppose 8 kilonewton per meter square, and live load of 0.75, as it will be a non-accessible part, and there will be only live load due to repairing purpose, like the people will be going there only for the repairing purpose, right, as it is a lift machine room. So I have taken a live load of 0.75 and dead load of 8 kilonewton per meter square, and I'll make it as a beam load bidirectional. Okay, and click on OK. So the basic loading, the basic slab loading, what I have already given here. So let's go to the drawing 1 first again, and now I'll be going with the beam loads. So go to uniform and individual beams. So select the beams. Let me select all the inner and outer beams, and I'll be keeping one particular value. See that there will be no live load, only dead load, so I want the dead load. See, it is in ton per meter. Okay, so let me take a value of 10 kilonewton, or sorry, anything, like you have to calculate the wall height and wall thickness. So here for time being I am taking, suppose 0.6 ton per meter, means 6 kilonewton per meter, and the self weight, again I do not want to assign the self weight here. Okay, so this values you have to calculate, actually it's not like the same value you have to keep, you have to calculate the wall loads. So it is 0.6 ton per meter, and click on OK. So you can see everywhere we have assigned the wall loads. And for the load drawing 2, again uniform, individual space. Now as it is a terrace part, it will be having only the parapet walls, right? So click, select first and click on any, again click on any of the beams, and keep the value as 0.2, means I want it to be 2 kilonewton per meter square, a meter, so it will be 0.2 ton per meter. So click on OK. So this is how we can assign the loads on our building using the auto strap. So the assignment of load is completed, the basic loading. Now what I'll do here, I'll go, see here I have option strap model. If you go to strap model, here there are some parameters, column parameters, and you have default parameters, like some, see in default parameter these things there is no need of changing actually. This submodel, here you have submodel connection points to walls. Okay, I'll explain all these things in my later videos. Okay, and you have the offset here, the beam offset inside the column, and you have this support at base level. So I'll just, if it is in pinned, I'll make the support at the base level at fixed here. So this is the only thing I'm going to change. And here it is showing that create rigid links in plane. Rigid links in plane means it is actually meaning you the telling you about the diaphragm. If you want to analyze the structure for seismic loads, okay, for dynamic analysis, it is very much important to assign the diaphragm here. So this diaphragm and all these things I'm not going to do it in straps, auto strap. I'll be doing it in strap software. Okay, so that you can understand that strap software much in a better way. So let me just, I have changed this one, I have made it fixed, and click on OK. Now I'll be going to this part which is create model, and let me write it to demo 2. I'll browse the folder. This is my demo 2, and I'll make, okay, this is my demo 2, and click on select folder. And see, I do not want to overwrite any model because I do not have any model there, and just use submodels. Now submodel means this drawings along with your structural element or structural mathematical model. You'll be having these drawings also in your strap software to check. Okay, so and create plane model means if you want to check only this part, only this plane or this floor, you can say, for analysis. So what will happen, this column points will be a fixed support. It will become, this columns will become a fixed support, the walls will become a fixed support, and you'll get the analysis result for the beams and the slabs. Okay, I do not want that. I want to create a whole mathematical model, so I'll be not checking this one. So I have selected this, use submodels, and click on OK. It will take some time to create the model. Okay, so the creation of the strap strap model from the auto strap is almost completed. Now what we can do, we can minimize the auto strap, and you can open the strap software. So this is my strap, and here this is the list, like the folder you have selected, whatever strap model is there available in that folder, it will be showing here. So I have created another folder which is called demo 2. So I'll go to files, change current folder, and I'll browse. So it is in another folder, so I'll go to demo 2 and click on open. See, this is my demo 2. So double click this demo 2, and here you have the model. See, I have the isometric view here. This is the panel where you will be having different tools, and this is the actually your main menu where you can take different options to create the model or to keep the loads and all. Okay, so and also this is the main menu. Here you have geometry option, loads option, results, weights, bridge. Okay, geometry means you have to create the mathematical geometry, so you can go to the geometry. You have loading part. So let me change the view to isometric view, and this is my isometric view. If you see the rendered model, so this is my rendered model actually, and you can see here I have to change the thickness of the slabs actually. So what I'll do, I'll escape, I'll go to my isometric view again. Now I'll be going to this element slab option, elements. I'll click on properties, and here you can see the thickness of 1.2. okay, it is already there. So click on this and click on define or revise. So as the unit is in mm, what you can do, you can make it to 120. The material will be obviously concrete, and click on OK and click on end. So this is the thing that I wanted to change. So let's check again. Now the thickness we have increased. Okay, and due to the meshing you can see the divisions in the beams also. Okay, due to the mesh of the slab. Okay, so this is my render option. I can change it actually. Now this is my mathematical model, and these are the foundation, you can see, fixed supports that we have assigned there. If you want to assign it here in strap, we have the restrain option, you have the fixed support, and you can do it to individual nodes like that. Okay, let me escape it. I do not want it now. Now another most important thing, that we have assigned some loads here, right? Let me see whether these loads are available in this strap software or not. Let's go to the loads tab, and here if you go to this existing load option, you can see the dead loads, the live loads are already available. Okay, if you and there are many other options which I will be explaining in my next video, like how to assign the wind loads, how to assign the earthquake loads. So this is it for this video. This is how a simple process to create a major project in your strap software. If you want to, I'll be creating videos. If you really want me to create basic videos on strap, like how to create basic geometries in the strap software itself, please let me know in the comment section, so that I'll be creating the basic videos, or you can say the basic tutorials of the strap software. Okay, thank you. In the next video we'll see how to assign different loads and how to analyze this the software. And if you really like this video, please give a thumbs up and subscribe my channel if you are not a subscriber, and you'll be getting the updates day by day in my channel. Thank you and bye bye.